All right, guys, today we are going to be looking at the quotient rule, which is the last what's considered basic derivative rule for calculus. And so we looked at product rule, and we noted that for product rule, when you take the derivative of two functions being multiplied together, it's not equal to their derivatives separately multiplied together. And you'll see that the same thing is true with the quotient rule. In fact, the quotient rule is even a little more complicated, but the same way that we, for product rule, try to remember it using like crisscross applesauce, we'll have kind of a verbiage for you to remember quotient rule as well. So first let's write it down. So if you have f divided by g, that's a quotient, the answer to a division problem, and you try to take the derivative of it. What your derivative shortcut ends up being is g f prime minus f g prime all over g squared. And there are proofs of this out in the world if you would like to go find one, but you just have to know it. So let's pick a function that we want to take the derivative of. So let's do h of x equal to 6x cubed minus 7 over, let's pick some other stuff, x squared plus 5x plus 4. Sure, okay. So in this example, looking at f divided by g, your f of x function would be 6x cubed minus 7, and g of x would be x squared plus 5x plus 4. So let's find the derivatives of f and g. So the derivative of 6x cubed minus 7, bring down to 3, multiply it by that 6 would be 18x squared, and then the derivative of negative 7, derivative of a constant, is 0, so that's just your f prime. And then the derivative of g would be, bring down the 2, so you get 2x. The derivative of 5x is just 5, and then the derivative of a constant 4 is 0. So these are your derivatives respectively. So therefore, if I would like to find h prime of x, we do the derivative of, the regular function g. And I'm actually trying really hard here not to use the shortcut rule for words as I'm saying it, and you'll see when we do this in class and in practice a lot. I'll kind of be sing-songing it. So we have that. So g times f prime, which would be, there we go, a little notation for us, the 18x squared. And then minus f times g prime, that's a g, all over g squared, so x squared. Okay, and sometimes depending on what your problem is, they'll have you simplify your answer. Sometimes if it's easy to simplify, or if like things cancel out nicely, but for the purposes of this example, we're not going to. And so I admit the derivative of the quotient is complicated. It's a lot to remember, and I remember the rule best in these words, and this is something that's kind of across calculus, across the board, is used. So when you are trying to find the derivative of a quotient, we use the words low, implying that your low function goes first, and then d high, which means the derivative of your high function, minus high, so your high function, and then d low. That's the derivative of your low function. And then at the end, so low d high minus high d low over low squared. And so those are kind of the words that you would see me struggling not to say up here, right, as I'm trying to keep track of which piece is which. So I did my low function, my low d high minus high d low over low squared. And you can kind of sing-song it to yourself, or if it makes more sense. But your low, here's the G. D high means F prime minus high, which is F, and then D low, which is G prime, and then all over low squared, which is G squared. So that's how you get low D high minus high D low over low squared. You are going to have to use the product and quotient rule several times before you remember them well. You can't expect to just pick it up in a day. You have to practice, but you guys know this. You're in calculus, so let me know if you have any questions.